I would like you to construct a query that tells us which genre are on which playlist. So so we would like to have in the output the name of the playlist, yeah, and the name of the genre. Yeah, that was requested. Name of the playlist, name of the genre. But that should not be all possible combinations, but only those combinations that are stored in the database where a genre is really connected to a playlist. Yeah. So we need the name of the playlist, we need the description of the genre, but we don't have any direct connection between it. So in order to combine that information, we need to find a path between the two. And this is via the title table. Yeah. And that's essentially every time, always you have to do it that way. If you're combining data from different tables, you have to find a path between them. Yeah, a path by means of foreign keys and primary keys, for example. Yeah. Okay, that's what I'm going to do here. So let's start with the join here. So we start with the playlist table. Playlist. And you remember we could give it short names, and I'm going to do that, calling it PL for playlist. Then we have the keyword join in order to join a table. And then we join it with the title table. Yeah. So we have to go playlist. We have to go via the title table. And then we need a join condition. And let's call it T, the title. And we have to say the title dot PLID must be the same as from the playlist, the PLID. Yeah. Then we need a further join with the genre table. And then we have to say, okay, on G dot GID. So the genre ID from the genre table must be the same as the genre ID from the title table. So now we have the join complete, and then we have to define the output. So we take the name of the playlist table. So select playlist.name as, let's call it playlist in the output. And the second thing is we take the genre description and call it genre in the output. Yeah, it's just a renaming for the output, or it's giving it a name for the output. So now we should have everything together. Let's execute it. So, and we see it's look like this solution, but not quite, because we have it. We have here chill out pop, but as you see, we have duplications in it here. So first of all, let's do the following. Let's order things, order by, and then we take the name of the playlist, and we take the description. We are ordering according to that. Yeah. So if you look at the result here, yeah, for example, we see chill out pop, chill out pop, chill out trip hop, chill out trip hop. So we see duplications here, but the thing I wanted to have is that the same table without duplications. First of all, why do we have these duplications? What do you think? Why? So if I go here,
Because there are two SIDs with the same ELID and GIDs,
yeah,
like for the first and second.
that's it. For example, if we take sit back down and I will fade, they both have the same PLID and the same genre, and therefore it gets connected, and therefore we get 2 times the same combination in it here. Yeah, and there's a simple way to do to make it unique. Yeah, I haven't explained it to you yet, but I do it now. Distinct. There's a keyword. It's called distinct. Yeah, and if you place distinct in front of it, then we have it as we wanted to have it. Yeah. So let's put it in the, I put it in the chat so that you can execute it on your computer. So the distinct simply looks at identical output and unifies it to one single output line. Yeah, if there are
Sir, can you please explain the join part once again, if possible?
yes, of course. So we are starting with the table playlist, yeah,
Yeah, yeah, Professor.
and so we are starting, for example, here we're taking chill out here,
Okay.
and chill out has the playlist ID number 1. Yeah, then we join it with the title table here. Yeah, so let's take that chill out with number 1 and then go over to the title table and take those titles here that have the same playlist ID. So
Yeah,
let's take the first one here.
yeah.
We
So
see
it
we have
will be
connected to sit back down, but we are not interested in the title here. That's not the goal here of that. But we want just via the title table. We want like to reach the genre.
yeah. So connect the genre title. Yeah.
Yeah, and then you see, okay, it says genre ID 2. We connect it to genre with ID 2, and then we see pop. And this is why we see chill out pop.
Okay. Okay, sir.
Yeah, that's the way how it works.
Okay, yes, sir. Thank you, sir.
Okay. Any further questions to that query here?
Yeah, Professor, can we go like other way, like instead of joining from playlist, like from table, then playlist, and again from table to genre? Yeah.
So we can have a different. So we cannot directly connect playlist and genre. That's not possible because there's no direct connection between playlist and genre. We have to go via the title
No,
table.
I was saying like from table, first connection to like playlist, and then next connection from title to like
Yeah,
genre.
yeah,
Title, playlist, title, genre.
yeah.
Yeah, is it possible?
Then I didn't got what you mean. So we have followed the following chain: playlist, title, and then genre. But we could do the
No,
same way. We could start with genre, then title, and then playlist. Is it what you mean?
no, I said like from title, like connection between from title to playlist, and next connection
Ah,
title to genre.
yeah, that would be possible.
Yeah.
So okay, you wanted to let's do it, yeah. So instead of starting with the playlist, you wanted to start with the title, yeah. So I just take the title here and replace it with a playlist. That's what you mean, yeah?
Yeah, 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 yes.
And okay, let's execute it here, yeah? And it also works.
Yeah, okay.
I don't have even to change the join condition, as you have seen, yeah? that doesn't matter because it doesn't matter if in which direction that equation is written down. So t dot playlist ID equals pl dot playlist ID or pl dot playlist ID equals t dot PID. That's the same because the equality is symmetric. Okay, then let's do the same thing again, but with a different model. So that's now more or less the same kind of thing I would like you to do, namely I would like to figure out which org units are involved in project. So name of all org unit that are related to projects. That means where at least one employee of that org unit is involved in a project. Yeah. So if Miller, for example, is in project CRM, customer relationship management, and Miller is in org unit company, then company is related to project CRM. Yeah. So I would like to see which org units are related to projects or involved in projects. Yeah. Fine. We've got a solution from Xavi. Let's see. I will take it here from the chat. And execute it. Here I am. And let's see. Of course, I have to switch my database. And here we are. And so let's see. We have 3 records here. And actually, I forgot what the real solution is, but we can figure that out. Yeah. So first of all, it looks. Let's see. It looks okay. Let's take the solution from Niraj and see if it delivers the same value. So first one from Xavi, second one from Chirab. So okay, only the distinct is missing. I will add the distinct here. So once again, so title CRM company. Oh, it's the other way around, and the ordering seems to be different. Yeah, but company accounting CRM, company accounting CRM, and plant restructuring and plant. Yeah, plant restructuring and plant. So both solutions deliver the same value. So let's look at the data and figure out if that is okay. Let's go here into the company. So for example, if we take here project accounting here, number 1, yeah, then we see in project number 1, we see that Miller and Sanchez are involved, but they are both in org unit 1, and org unit 1 is company. So company is in it. So then let's take plant restructuring. Plant restructuring is number 2 here. Project ID number 2 has also 2 members, 7 and 8. 7 and 8 are Stone and Joe, and they both are in plant. Therefore, plant is in there. And the last but not least, we have CRM number 3, and there's also only Miller, and that's company. So perfect solution for both of you. Yeah. So we see, okay, these are the let's take this one here. The company is involved. The org unit company is involved in 2 projects, and plant is in 1 project. Yeah. And the solution was now in this case a join among 4 tables. Org unit, employee, employee, project, project. Yeah, you see now we have a join with 4 tables. Okay, thank you very much for that solution. Are there any questions to the solution? And also here you see it has been done in different sequence, yeah, the tables. And as before, it doesn't matter as long as the connections are correct. Okay, then let's go ahead. So the next thing I'm going to do, and this is something I'm going to explain and not to, it's not an exercise. We have this, and let's do it as follows, just a moment. So we have this recursive foreign key here, yeah, as you see, this recursive foreign key that points from the org unit onto itself. And you might remember that related to that is this hierarchy here, yeah. So let's also take that one here and put it into the okay, let's go here. Here we are. Is it possible to just a moment? So now we have everything together. Yeah, I would like to have together. So we have this self join here from the org unit table onto itself. And that means that we have a hierarchy company, F&A, controlling here, yeah, production, plant, and warehouse. And if I would like to show this hierarchy, at least these levels here of the hierarchy, I have to join the table with itself. And that is what is happening here. So we have the org unit table here, as you see, yeah, and let's mark it here, yeah. So as you see, we have the org unit table, and we have the org unit table here. It's 2 times the org unit table. And in order to do so, they need to have different names, and I have given them useful names. You could regard the org unit table within these queries to be in 2 different roles, namely the role as a parent and the role as a child. Yeah, as a parent org unit and the child org unit. And therefore I have given it the name parent and child. And the point is that if I join these 2 tables, I also need a join condition, and the join happens as follows. From the child, the supper unit must point to the OUID of the parent unit. And therefore you see child.supper unit equals parent OUID. And if you execute that query, yeah, so let's put it here in the chat so that you can execute it on your own. Yeah. If you execute that, you get that resulting table here. And then you see, so you see companies refers to itself. This is this circle here, this circular dependency. Company F&A points to company, and production points to company, and controlling to F&A, and plant to production, and warehouse also to production, yeah? So that's the result of that query here. And that's called a self-join. And that is also something that is not exotic or problematic or so, it's quite common, yeah, that you have such kind of hierarchy and you would like to deal with the hierarchy, the levels of the hierarchy. Okay, then that's
So the names that we give parent and child, that has to be like we can give any name or it
yeah.
is distributed in the tables.
Yes, you can give it every name as you like.
Okay.
Yeah, if you call the one A and the second B, and then you do it consistently here over all the query, it works in the same way.
Mhm.
But of course, especially if you have such kind of recursive or if you have such kind of self joins and so on, if you have the same tables two or more times within a query, then useful role names help in understanding tremendously. Yeah.
Mhm.
Therefore, I've called it parent and child. Fine. So up to now, we have more or less used the join in order to combine data from different tables. And we have seen 2 tables, 3 tables, 4 tables. Yeah, we have data joined. And now I would like to show you an example where we really do something more complex as just combining data, but also doing a complicated calculation. So you remember, yeah, at the beginning of our SQL lectures, I have talked about calculated columns, calculations that you can perform within the output of in the output, yeah. And now we are going to combine it with the join. And so the scenario I now would like you, I would like to implement within the query is to deal with project cost per employee. And so of course, all of you know, if we do some kind of project controlling, yeah, this also is done within companies. Project controlling deals with figuring out if a project is over its budget, yeah, if it's within in its time frame, and so on. And the thing I now want to calculate is as a first step, as some kind of budget control, is I would like to figure out the cost each employee here delivers to the project. No? And the idea behind so such kind of cost schemas, of course, is to have some kind of pragmatic solution. You have to find a sensible way to allocate costs, yeah. And in this case, since we only have a labor cost, yeah, in our database, and we have not material cost, yeah, we only consider, so we are going to consider labor cost as an indicator of the project cost per employee. Yeah, and usually that is also something you know, that costs that have some kind of fluctuation or that could change a lot. It's usually not so well suited for such kind of things, yeah, and therefore we as a labor cost we don't consider bonus, but only salaries. So the salary here is an indicator of the cost, and now we have to figure out how it is allocated, and therefore we have the following assumption, namely that we have 40 hours work time per week. Yeah, and we also in order to simplify things here, we just assume that the project lasts exactly 1 year. Yeah, and having made these assumptions, yeah, you can, so taking the salary here and taking the project relationship, what do you think might be a good idea? So if Miller, for example, has a salary of 100,000, what amount should be allocated to a specific project, for example? What do you think? What information
We
do
can
we
look in
need?
the number of project Miller is working.
Yes, number of hours. And we have the number of hours here in the employee project table. And how would you allocate it? For example, if somebody is working 10 hours, yeah? And for example, this one here in project number 3, that is Miller here, yeah? So if, what do you think? What amount should be allocated to project CRM via Miller if he's working 10 hours and we have 40 hours a week?
Should it be less than 10,000 or equal to 10,000 means because that is the budget of the department? Is it
10,000
like
is the
that?
budget. Actually, we are not talking about budget at the moment. It's just for later. I just wanted to figure out the amount Miller is allocating to CRM, and that's not 10,000.
We will try to see who all others are also working on CRM.
Yes, but let's concentrate on Miller. So the question is, what
100
is
into 10.
Can we divide like
4 times the number of hours.
4 times?
40 hours he's giving then. A week.
so like
You
number
got
of
the right
hours?
track, Shavi, but is this 4 times or what is it? So we have 40 hours per week. And he's working 10 hours per week on that project.
So, should we divide 10 hours with the salary and then multiply it?
It is dividing the salary by 4.
Yeah, exactly. Because if he's working 10 hours, it's a quarter of his weekly work time, isn't it?
Yeah.
Mhm.
And therefore, it makes sense to take a quarter of his salary, doesn't it?
Yeah.
Yeah. So that's the idea.
So we take 25,000 divided.
25,000, yeah, and you immediately see that CRM is over budget, yeah, in that case. But that is something we will calculate later on. But for now, please construct a query that delivers per project member the amount of cost, he is incurring, the project is incurring by him. So let's, I've done it here. That would be the result. You see, for example, Miller is working on CIM with 10 hours, so it's 25,000, yeah? And Miller is also working, if we look at number 1 again, also 10 hour on accounting, yeah? And therefore, accounting has 25,000 by Miller and 20,000 by Sanchez, yeah? So it has, overall, it has 45,000, but for the time being, we considering only the individual record here per employee and project, yeah? The other thing will come later. So I would like you to build a query that is able to deliver that table here. Is it clear what I want you to do?
Yes.
Professor, could you please explain that once again?
Yeah, of course. So as we have seen, each employee like Miller is allocating costs on a project, namely via the number of hours he works in that project. Yeah. So Miller, for example, is in project number 3, and number 3 is CRM with 10 hours involved. and that's a quarter of his salary, and therefore a quarter of that amount here is allocated to that project CRM here. Yeah, and then I can take Sanchez and all the persons who are involved in projects and can take their corresponding fraction of time and take the corresponding fraction of his salary and output that as a cost element. Does it clarify what I wanted to have?
Could you please go back to the previous table? So here you want to say from the salary of 100, he is contributing 100 by 4. That is 25 to the CRM department, isn't
Exactly. That's correct.
it? Okay. So that 25 and he's working for 10 hours. So 250 be the his contribution if weekly contribution, isn't it?
Yeah. So the standard weekly the standard weekly work hour is 40 hours.
Okay.
And the actual hours he is working on that project is stored in number of hours. And so if somebody is working 10 hours, he is working a quarter of his time.
Okay.
Yeah. So actually it's a fraction. It's the number of hours divided by 40. That's
Yeah,
a
I
fraction.
understood. Yes.
And you see, that's a calculation, isn't it? And that is something that you have now to combine with join, because you need information from those three tables here: employee table, number here, employee project table, and project table, and you need to calculate things. Yeah, and that is what you should carry out. So I will give you some time for that. If there are no further questions, or are there any questions? Let's take a closer look at it. Yeah, the first thing that has to be done, of course, is to provide a join. And actually, in this case, for example, the org unit is not wrong here, but it's not needed. So if I take here Niraj's query, yeah, and remove that one here, yeah, I think it should also work. Yeah. So of course you can have a larger join as is needed, but of course it's more better. You have a better performance if you have less join, not unnecessary joins in the query. Yeah. Okay, the join itself, it's clear. It should comprise the employee table, the employee project table, and the project table. Employee project. Yeah, and please always remember, EID must equal EID and PID must equal PID. That must always be the case. Yeah, that the join is correct. So that's the join as we know it. And now we have a calculation in the output, namely salary times number of hours divided by 40. Yeah, and here we have parentheses, and here we don't. In this case, because multiplication and division are on the same level, it's no problem. But as soon as you have addition and multiplication, of course, you need to correct parentheses. Yeah. In this case, it's not necessary, but I think it clarifies thing, because that here is a fraction. Yeah, and therefore it's perfectly okay to have a parenthesis here in order to see that's the general idea. Yeah, both solutions are correct.